we are attempting the AP past paper of year 2022 and we are attempting the structured questions. So in the question they are saying a student reacts 0.3 gram of methyl salicylate with a stoichiometric amount of a strong base. This product is then acidified to produce salicylic acid, which is this one. They are saying for every 1 mole of this, they would form 1 mole of salicylic crystals. Calculate the maximum mass of this acid. So you have methyl salicylate C8H8O3, and from this you are forming an acid which is having crystals HC7H5O3. So from 1 mole you are forming 1 mole as well, and then they have given you the mass which is 0.3 gram. First you have to find out the mole of C8H8O3, that is mass is how much there? 0.3 divided by molar mass is 152.15, and the answer that comes out to be is, the answer is going to be, let me calculate, that comes out to be 0.00197, and you know, like C8H8O3 ratio HC7H5O3, so it is having 1:1. As you know, 1 mole is forming 1 mole, so if it is going to be 0.00197, that is also 0.00197. so these are the moles of this much. And for mass, if you want to find out mass is equal to mole times mr. Mole is how much? 0.00197 times mr is 138.12, and the answer comes out to be 0.272 grams. So for the next question, as part of the experimental procedure to purify the HC7H5O3 crystal, after the reaction is complete, the crystals are filtered from the reaction mixture, rinsed with distilled water and dried. Some physical properties are given in the table below. Melting point is given, solubility is given, and specific heat capacity is given. Now they are saying the students' experiment results in an 87% yield of dry HC7H5O3. The students suggest that some of HC7H5O3 crystal dissolved in distilled water during the rinsing step. So what is rinsing step? Like for example, you have got the crystals of the acid and you are washing it with the water. Okay, you are washing it with the water, and when you are washing it with the water, the student is saying that some of HC7H5O3 has been dissolved. That's why we are getting the product only 87%. So what do you think, it is right or wrong? So I would say it is right, because you know it is acid and acid is soluble in water, and when acid is dissolved in water, the precipitate's mass becomes less because some part of this acid has been dissolved in water, which decrease the mass of these precipitates. So how I am going to write it? So this is going to be the right explanation for them, because acid is soluble in water. That's why some of the precipitate would dissolve and would cause the yield to be less than what was expected. Moving towards the next question, given the physical properties in the table, calculate the quantity of heat that must be absorbed to increase the temperature of 0.015 gram sample of dry acid crystals from 25 degrees Celsius to melting point of 159 degrees Celsius and melt the crystal completely. So for melting, we have another heat which is Q of melting, and for the other heat is going to be so we have to calculate two heats. One is to raise the temperature from 25 to the melting point, and the other is to melt the crystals completely. So Q heat, for Q heat we need to use the formula mc delta T. M is the mass, which is 0.105, and specific heat capacity has been given to us in the question, that is 1.17. And for delta T, as the temperature is raising from 25 to 159, so 159 is the final temperature minus initial temperatures, that is 25, and the answer comes out to be 16.5 joules. And for Q melting, we have to use the formula number of moles multiplied by heat of fusion, which is in kilojoules per mole. So you have to multiply it with 1000 to convert it into joules per mole. So by multiplying, it comes out to be 27,100 joules per mole. And when we are multiplying with the enthalpy of fusion, you are going to see moles are how much. Moles we can calculate. Mass we are given by molar mass 0.105, and molar mass is going to be 138.12. Enthalpy of fusion is 27,100, and the answer comes out to be 20.6 joules. And when you have to add both of them, Q of heat and Q of melting. So when you are adding them, Q is equal to Q heat plus Q of melting. The answer is 16.5 plus 20.6, so it is going to become 37.1 joules. This is our final answer. The structure and melting point for methyl salicylate and salicylic acid are shown. The same three types of intermolecular force, London dispersion force, dipole-dipole interaction, and hydrogen bonding exist among molecules of each substance. Why the melting point of salicylic acid is higher than that of methyl salicylate? The reason is that as there is hydrogen bonding is present, so you can see that this salicylic acid that can form two hydrogen bonding. You can see, and from this part as well. And this will also only have one hydrogen bonding. Okay, so this one is having only one hydrogen bonding. So you can write here that salicylic acid has the higher melting point because it has more hydrogen bonding as compared to methyl salicylate, which has only one hydrogen bonding. So how I am going to write the explanation? So this is going to be the right explanation, that molecules of salicylic acid, they have more hydrogen bonding than molecules of methyl salicylate. Because of that, it is going to have strong intermolecular force and thus have high melting point. Now for this part, a student titrates 20 milliliter of 0.1 acid with 0.02 NaOH. Use a probe to monitor the pH of the solution. The data are plotted producing the following titration curve. So for this one, you must need to know one thing, that in this region you have volume of NaOH which is 10 up till the equivalence point have been started. So first you need to find out where is half equivalence point. So half equivalence point is going to be that point where half of the volume of NaOH has been used before it reached to the equivalence point. So total is 10, half is going to be 5. So this is going to be the half equivalence point. That is the half equivalence point. And the pH that has been at this point is going to be the pH, and that pH is equal to pKa. That is pKa at this point. And half equivalence point, the pKa here is 3.1, because that is 3.1 that is present at the half point where the half volume of NaOH has been used. So pKa comes out to be 3.1. When the pH of the titration mixture is 4, is there a higher concentration of the weak acid or its conjugate base in the flask? So you can see one thing, they are saying when the pH is 4. The pH is 4 at which point? pH is 4 at this point. You can see. So at this point, because at half equivalence point, that is the point where the half amount of acid and base has reacted. So the conjugate base that is forming from this acid, the conjugate base is going to be C7H5O3 minus, that is a conjugate base. So at half equivalence point, what is happening? Equal amount of HC7H5O3 is equal to the concentration of C7H5O3 minus. So it is this point where the half quantity has been used. But at this point you are going to see that as it is above than equivalence point, half equivalence point, then more amount of this is present. More amount of conjugate base will be present there. Conjugate base will be present because it is above than half equivalence point. So how I am going to explain this thing here? So this is a correct way of explaining this thing, that conjugate base C7H5O3 minus, when pH is equal to 4, the titration is beyond the equivalence point, where at equivalence point they both are same, the concentration are same. So above half equivalence point, what is going to happen? This conjugate base would be present in more quantity. For the next question, the student researches benzoic acid and finds that it has similar properties to salicylic acid. The K for benzoic acid is 6.3 times 10 to the power minus 5, and they want you to calculate pKa. So the formula for pKa is negative log of Ka, and negative log of Ka is how much? 6.3 times 10 to the power minus 5, and the answer comes out to be 4.20. For the next question, a student performs a second titration, this time titrating 20 milliliter of 0.01 benzoic acid with the solution of 0.02 NaOH. Sketch the curve that would result from the titration of benzoic acid on the following graph, which already shows the original curve from the titration of 20 milliliter of 0.01 salicylic acid. The initial pH of benzoic acid solution is 3.11. So we have to draw a graph. Remember, the concentration of NaOH is same there. So when we have to draw the graph, first thing is that they have given the pH of benzoic acid is at 3.1. And now, if we want to choose the half equivalence point, we know half equivalence point is at this point. And what is going to be the value of pKa? That is 4.20 that we have found already. So 4.20 lies somewhere at this point, at the half equivalence point. So this line has to pass through this place, and then it needs to go like this. And at this point, as the concentration of NaOH is same, so it will also remains the same. The important thing that we must know, that pKa of benzoic acid is 4.20, that must need to be at half equivalence point and the graph must need to pass through it. So in this question they are saying methanol vapor decomposes to form carbon monoxide gas and hydrogen gas at high temperature in the presence of platinum catalyst. There is a platinum catalyst. It is given in the question that enthalpy change is 90 kilojoules per mole. But as I have taken it into this form, so I have missed that thing. So this is given in the question. The enthalpy is given in the question, just remember. So now they are saying CH3OH is going to form CO plus 2H2. So hydrogen oxidation state here is going to be +1 because hydrogen has +1 oxidation state except with metal hydrates from group 1 like NaOH, NaH, KH, RBH, where it has the oxidation state of -1. Otherwise hydrogen has the oxidation state of +1 every time, and as it is changing from +1 to 0, so you know that as the oxidation state of hydrogen is changing from +1 to 0, that means it has gained electron, so it is going to be reduction. So H atom are reduced as oxidation number is changing from +1 to 0. Now you have to draw the Lewis diagram of carbon monoxide. For Lewis diagram, first what we need to do, we need to find the valence electron. Carbon is having 4 valence electron, oxygen is having 6 electrons. So when you add them, they become 10. So the first process is to write down the bonding electrons. One pair of electron will come here. Rest of the electrons will come here 3, 4, 5, 6, 7, 8. And for carbon, as there are 4 electrons in the valence shell, so 8 and 2 will come here. But the octet of carbon has not been completed, so what we need to do, we are going to remove these 2 electrons. We will bring it here. Now still the carbon has 6 electrons, so octet has not been completed, so we will be removing the electrons from here and will bring it at the center. So now in the AP, like what we need to do, there are 3 bonds, look like 3 pair of electrons, so we are going to draw 3 bonds here like this. So this is going to be the final description of it. For the next question, they are saying the value of standard molar entropies of the compound involved in the reaction are given in the following table. Use the table, data in the table, calculate the value of standard entropy change. So entropy change here is going to be summation of entropy of products minus summation of entropy of reactant. This is the formula. And for product, we know the equation is CO plus 2H2 is forming it's the reverse of it. That's going to be CH3OH, and that is forming CO plus 2H2. So entropy of product is carbon monoxide, that is 198, plus 2 of hydrogen, 2 times hydrogen 131, because there are 2 hydrogen molecules there. So minus entropy of reactant. Entropy of reactant is CH3OH, so 240 will come here, and then the answer comes out to be 220 joules per Kelvin mole of reaction. Then for this part, they are saying calculate the value of delta G. Delta G is equal to delta H minus T delta S. Delta H is given to us in the question, that is 90 kilojoules per mole. For 90 minus T is going to be, temperature is 375, and entropy change we have calculated, it is in joules, but we have to convert it into kilojoules. For that we are going to divide that by 1000, 0.220 kilojoules per Kelvin per mole. So I'm going to multiply with 0.220. So the answer of delta G that comes out to be is how much? That comes out to be is 7.5 kilojoules per mole of reaction. For the next question, the following particle level diagram shows a representative sample of the equilibrium mixture represented by the equation above. So CH3OH is having how many molecules here? 1. Carbon monoxide is having the molecules which are 3, and hydrogen is showing the molecules 1, 2, 3, 4, 5, 6. They are saying use information for the particle diagram to calculate the partial pressure of carbon monoxide. So for carbon monoxide, we are going to put 6 at top. Total are 10. 10 molecules are there, 6 plus 3 plus 1, they are 10. Multiply by total pressure, that is 12. So answer that comes out to be is 3.6 atm. So write the expression for the equilibrium constant Kp for the reaction. Kp is equal to the product over reactant. Product is partial pressure of CO times with the partial pressure of H2 whole square. Why square there? Because there are 2 moles. Divided by reactant, we are putting partial pressure of CH3OH. So for the next question, they are saying the reaction system represented by the equation is allowed to achieve equilibrium at different temperature. The following table gives the partial pressure of each species in the equilibrium mixture. So what you need to do, like to find the value of Kp, you are going to put the values in the formula, that is partial pressure of carbon monoxide times with the partial pressure of H2 square over, it's going to be partial pressure of CH3OH. And for partial pressure of carbon monoxide, that's going to be 4.2 atm times with 8.4 for hydrogen square, and at bottom it's going to be 2.7. So the answer comes out to be 110. So for the next part, they are saying the volume of the container is rapidly doubled with no change in temperature. As equilibrium is re-established, does the number of CH3OH increase, decrease, or remains the same? Justify your answer by comparing the value of reaction quotient. Reaction quotient, you are going to put the new values. First of all, when volume is doubled, you have to recognize this thing, pressure becomes half. Why? Because pressure and volume, they are inversely proportional. So when pressure becomes half, this would become around 1.35, this would become 2.1, this would become 4.2. So Q here is going to be, by putting the values in the above equation, it would become 2.1. For hydrogen, that's going to be 4.2 whole square, and for PCH3OH it becomes 1.37. So the answer comes out to be, so the Q comes out to be 27.03. As the value of Q is less than Kp, so you know, as the Q is smaller than Kp, then equilibrium move towards product side. So when equilibrium move towards product side, where we have like CO and H2, So we are going to see that there is going to be decrease in the moles of CH3OH. So we can write that the moles of CH3OH decrease as equilibrium move towards left hand side, where there will be more reactant. For the next question, they are saying write the complete ground state electron configuration of an aluminium atom. Aluminium atom has 13 electrons. So that's going to be 1s2, 2s2, 2p6, 2 plus 2, 4, 6, then 3s2, then 3p1. So for the next question, they are saying based on the principle of atomic structure, explain why the radius of aluminium atom is larger than in the radius of aluminium ion. You know, first electron occupies 2 electron, first shell, and second shell 8 electrons, third shell 3 electrons. So when it becomes aluminium ion, then that is going to be 2 8. This is aluminium, this is Al plus 3. So we can write here the explanation that when it becomes aluminium ion, then the number of shell becomes 2, okay, and when it becomes 2, then it causes the decrease in the distance from the nucleus. So how can we write it? Okay, so next question. A student plans to combine solid aluminium with an aqueous solution of silver ions. The student determines the mass of solid AgNO3 need to prepare the solution with specific concentration. So they are preparing a solution. In the following table, briefly list the steps necessary to prepare 200 milliliter of aqueous solution of silver nitrate. Now, we have to write down the steps that are involved in making a solution. So first of all, we need to have the volumetric flask. This is a volumetric flask, and first they are saying use weighing paper to determine mass of solid AgNO3 on a balance. So we have to measure the exact quantity of AgNO3 and we have to put it on the balance. Next, what you need to do, you are going to put that AgNO3 into the flask. Afterwards, before that, you are going to partially fill this state of in water, like partially fill the volumetric flask with some distilled water, and then add the weighed AgNO3 that you have weighed. You are going to add that weighed quantity, that is basically in solid states. You are adding that weight quantity which you have weighed on the balance into the volumetric flask. And afterwards, what you need to do, swirl to dissolve the solids. You are going to mix it in water, swirl to dissolve the solid. You are going to mix it, and then in the end, what you need to do after the solid is dissolved, then what you need to do, there is a calibrated flask. You are going to put the water up to the mark. Okay, so after the solid is dissolved, fill the flask with water, fill the flask to the calibration point, which is at 200 milliliter. So this is a 200 milliliter flask, and there is a mark over there. So first what we have done, we have put the solid of AgNO3, then we have added some quantity of water, let's say, and we have swirled it, and after swirling you have to fill the this volumetric flask up to the calibration level, which makes the total solution for 200 milliliter. So in this question, after preparing the solution, the student places some of the solution into a beaker and add a sample of aluminium. The reaction represented by the following equation occurs. You can see aluminium solid and silver ions, they have 1:3 there. And if you are seeing here that we have 4 aluminium and how many silver ions are there? 8. But according to equation, 1 mole of silver aluminium solid, they are reacting with 3 moles of silver ions. So you are having 4 aluminium, you are having 8 silver ions. So you can see, like, if you are having 1 aluminium and they are reacting with 3 silver ions, now you have, if you have 2 aluminium, let's say these are aluminium and these are silver ions. Now if you have 2 aluminium, they are forming 6 silver ions, okay. But if you have 3 aluminium, you are going to have 9 silver ions. But in fact, what is happening here, you have maximum 8 silver ions. So silver ions are basically in a limiting quantity. So what happens, like only 2 aluminium, as you know that you are having 4 aluminium there, so only 2 aluminium will be reacting to produce 6 silver ions, and 2 aluminium will stay there because they were total 4. So if there are like 2 aluminium, so the remaining aluminium are 2, so that is why you are seeing 2 aluminium. And as like there are 2 aluminium, so you can see one thing, that 2 aluminium would be converted into aluminium ions. So that would be forming 2 aluminium ions. So I am writing 2 aluminium ions here. And one thing more you can see here, that how many silver ions they have converted to silver solid. So you are going to see that only 6 would be converted into silver solid. So I am going to write silver solid here. Silver solid, I can put it at the bottom. Yeah, now these are silver solid that has been formed. So how many of them are remaining, like how many silver ions would be remain, as total were 8 and only 6 are converted into silver solid. So 8 minus 6, that is 2. So only 2 silver ions would be remain there, Ag positive, 2 silver ions would be remained. Finds the standard reduction potential given in the table, which are related to the reaction that occurs. So first of all, we have two E naught values. So the one which is going to be more negative, that is going to be anode, and the one which is going to be positive, that's going to be cathode. So they want us to find out the value of E naught. E naught is equal to E naught of cathode minus E naught of anode. So E naught of cathode is 0.80 minus anode is minus 1.66, and that comes out to be 0.8 plus 1.66, and that is going to be 2.46 volts. Based on the value of E naught, Would the standard free energy change of the reaction under standard condition? Delta G be positive, negative or zero? So we have a formula that is delta G is equal to minus NF E naught. So by putting the value of E naught, which is going to be positive, delta G comes out to be negative. So you are going to write that it is going to be negative as the E naught has a positive value and would therefore delta G will have negative value. For the next question, once the reaction appears to stop progressing, would the change in free energy gives delta G be positive, negative or zero? So first of all, if the reaction appears to stop progressing, then at that time delta G is going to be zero, because there is an observation that the reaction stop progressing. What does that means? That means it implies the equilibrium is established. That implies the equilibrium is established and delta G becomes zero. So that implies the equilibrium has established and delta G becomes zero at equilibrium. So answer the following question about the compounds NH2Cl and NCl3. The Lewis electron dot diagram of the two compounds are shown. Calculate the number of moles of NH2Cl. Molar mass is 51.48 gram per mole, present in 1.0 liter of solution in which the concentration of NH2Cl is this. So you are given with the concentration and also you are given with the MR. If you want to find the number of moles, you are going to do concentration divided by MR. Concentration is 0.0016 gram per liter, and over it you are going to have the molar mass, which is 51.48 gram per mole. So what happens there, that it is going to become 3.1 times 10 to the power minus 5 moles. So NH2Cl is highly soluble in water, whereas NCl3 is nearly insoluble. So in both of the cases, you are going to see one thing, like this is hydrogen, and this is Cl having a lone pair of nitrogen. So it can form a bonding of hydrogen bonding with water. Okay, like it can forms the hydrogen bonding with water like this, partial negative charge lone pair. So even NCl3 can also form hydrogen bonding with water. Okay, this is hydrogen bonding, that is they are trying to establish with water. So in fact what happens, both can form hydrogen bonding, both have dipole attraction to water. But what happens, in fact, why it is highly soluble? Because it is developing the more stronger force of attraction between their molecule and water. Instead, it is having less force of attraction. So in fact, both are having hydrogen bonding and dipole, but due to like NH2Cl molecule and water, they are developing the stronger force of attraction, so their solubility is more. How I'm going to write it? So this is a correct way of writing the explanation, like as both of them are developing hydrogen bonding with each one of them, and they both are developing dipole-dipole attractions as well with water, but the intermolecular force between NH2Cl molecule and water are stronger than those between NCl3 molecule and water, which leads to greater solubility of NH2Cl in water. For the next question, they are saying the value of enthalpy of vaporization for NCl3 is 32.9 kilojoules per mole. Calculate the amount of energy required to vaporize a 15 gram of sample of NCl3. So if you want to calculate Q, we know one formula, enthalpy is equal to Q by N. If we want to find out Q here, enthalpy of vaporization going to be time with the number of mole. Enthalpy of vaporization that they have given to us is 32.9 times with the moles of NCl3. So that is going to be mole is equal to mass over molar mass, which is 120.36, and the answer that comes out to be is 4.10 kilojoules. So this question, the following equation represent the decomposition of N2O5, for which the rate law is rate is equal to K times the concentration of N2O5. This is an equation that has been given to us. A sample of pure N2O5 is placed in an evacuated container and allowed to decompose at constant temperature of 300 Kelvin. The concentration of N2O5 in the container is measured over a period of time, and the measurements are recorded in the following table. So you can see one thing, first of all, it is first order, and you can see here that what is happening, the concentration is getting half. So half-life for it is going to be, half-life is the time at which the concentration becomes half, so that is going to be 1.67 hour. And the formula for to find the half-life is going to be, for first order, that's going to be 0.693 divided by 1 divided by K. So if you want to find out K here, 0.693 divided by T half-life, and that comes out to be 0.693 divided by half-life, which is 1.67, and the answer that comes out to be is 0.415 per hour, because that is hour, and when it goes up it becomes per hour. So this is going to be the right explanation for this one. We can write it. Yes. So for the next question, they are saying we have given different steps here, and step 1, step 2, step 3. Suggest identify which step of the proposed mechanism is the rate determining step. So first of all, rate equation is rate is equal to, that is given to us, K times the concentration of N2O5. So you can see that is a first order, and in the rate equation you must know one thing, that the one which is going to be the concentration, that is N2O5, we have to find out that reaction. So if you see step 1, in step 1 you can see the reactant is N2O5, that is present in the rate equation. So this is going to be the rate determining step, because in the rate equation the concentration of N2O5 is 1, and the step 1 is the one which is showing the concentration of N2O5 only. So how we are going to write it? So step 1 is the rate determining step, as the rate law of elementary step 1 is rate is equal to K concentration of N2O5, which is consistent with the uh, first order kinetics. So this is going to be the answer. They are saying if this experiment was repeated at the same temperature but with twice the initial concentration of N2O5, would the value of K increase, decrease, or remains the same? So first thing, that the K value of K does not depend on concentration. Value of K is only dependent on temperature only. So if the concentration is changing and the temperature remains same, there is going to be no effect on the rate constant. So we can write one thing, that remains same. Why it remains same? Because the rate constant K is independent of concentration, and will remain the same at same temperature. The next question, a student wants to determine the concentration of permanganate in a solution. The student plans to use calorimetric analysis using solution containing MnO4- which have a purple color. To determine the optimum wavelength of experiment that measure the concentration of MnO4-, the student takes a sample of solution and measure the amount of light absorbed by the sample over a range of wavelengths. The data are plotted and identify the optimum wavelength. Optimum wavelength is going to be the one in which the curve is going to be at highest position. That's going to be this point. So if you see this point, that is going to be 525 nanometer. So answer is 525 nanometer. The student uses stock solution of 2.40 times 10 to the power minus 3 molar KMnO4 to prepare the standard solution of MnO4- that are needed to construct a calibration curve. The student used 100 milliliter graduated cylinder to measure a certain volume of KMnO4 stock solution. What volume should the student record? So if you see this diagram, the volume that is going to be is at lower meniscus. This area is going to be lower meniscus. So we have to find the lower meniscus here, and that comes out to be at 90, 91, and that's going to be at 92 milliliter. So calculate the volume in milliliter of 2.40 times 10 to the power minus 3 molar KMnO4. That is required. So you need to find basically volume, which is going to be V1, and that is molarity, we can keep it M1. That is required to produce 100 milliliter, which is going to be V2, and molarity here is going to be M2. So we are going to have the formula V1 M1 is equal to V2 M2, and as we know that V1 is equal to V2 M2 divided by M1, so that's going to be V2 is 100 milliliter. Okay, we can keep it in the same unit, that is milliliter, and times it with the M2 molarity, that is 1.68 times 10 to the power minus 3, and M1 is going to be 2.40 times 10 to the power minus 3, and the answer that comes out to be is 70 milliliter. So the student designs the following procedure to produce a calibration curve. Prepare several standard solutions that have known MnO4 minus concentration by dilution of the stock solution. In that thing, rinse the curvette with distilled water, rinse the curvette with the standard solution and fill the curvette with standard solution. So this is a very important point which needs to be done before the measuring the absorbance. Like you have to rinse the curvette with the standard solution, so there is should be no like dilution with water. Measure the absorbance of the standard solution with the calorimeter. Repeat steps 2 to 4. Now when they have plotted line of best fit, they are going to see that one point is below the line of best fit. They are seeing why it is going to be like this, why the absorbance is lower. So the thing is that like the students, they have not done the step 3 correctly. Like they have not rinsed the curvette with standard solution and before absorbance. That's why dilution occur with water, and that's why we are getting the value which is of absorbance, which is going to be the standard value. So how I'm going to write the answer? So this is the right explanation for that. The student would have improperly executed step 3, which is basically the rinsing with the standard solution, and because of that what happened, there'll be, like you can say, the standard solution will be diluted by the remaining distilled water and the absorbance would be lower than what it should be. So a Lewis electron dot diagram of oxalate ion is shown. Identify the hybridization of valence orbital of either carbon atom in the oxalate ion. So this is carbon atom. So it is going to be S, sp, sp2. And if it is sp2 hybridized, you can write here that it is going to be sp2 hybridized. Then they are saying write the expression for the solubility product constant Ksp for Ag2C2O4. So if we want to write the solubility product constant, you can first need to develop the equation Ag2C2O4. That's going to form 2Ag positive plus C2O4 minus 2. So Ksp is the solubility product. That's going to be Ag positive whole square, and that's going to be C2O4 minus 2. Calculate the molar solubility of Ag2C2O4 in neutral distilled water. So we have to calculate the molar solubility. How we can do that? They have given us the value of Ksp, that is going to be 5.40 times 10 to the power minus 12, and we can keep the solubility of them is as S. Okay, so that is going to be how we can do that. You know, they are forming 2S because S is for Ag positive, so they are forming 2S, and that is forming only S. So it comes out to be 2S here, and that is square, and that is S, and Ksp is going to be 5.40 times 10 to the power minus 12, and when it comes 5.40 times 10 to the power minus 12 is equal to 4s square times s, that becomes 4s cube, and s cube is equal to 5.40 times 10 to the power minus 12 over 4, taking cube root on both sides. So you are going to have the answer as s is equal to 1.11 times 10 to the power minus 4 rarity. So in this question they are asking the molar solubility of Ag2C2O4 increases when it dissolved in 0.5 molar HClO4 instead of neutral distilled water. Write a balanced net ionic equation for the process that occurs between species in solution that contributes to the increased solubility of Ag to C2O4 in HClO4. So first of all, from HClO4, you are getting hydrogen ion plus ClO4 minus, and from Ag to C2O4 you are getting 2Ag positive plus C2O4 minus 2. So this one hydrogen and they will combine, so C2O4 minus 2, they are in aqueous form, that is also in aqueous, that is in aqueous as well. So that is combining with hydrogen ions and they are going to form both in aqueous, and they would be forming HC2O4 minus 2 is changing from minus only. So this is the net ionic equation.